We're going to be talking about hardline communication systems. In a confined space application, hardline communication system increase your reliability for communications, and they afford your rescuers a lot more freedom within the space to perform other functions. If they're using a device, even in some hardline applications that require any type of button pushing or activation to link up or key up their mics to allow them to communicate, that's going to create some potential problems. There are some confined spaces that we're going to get into that will not enable us to manipulate our hands as freely to portions of our body. For example, if we're crawling through a 20-inch pipe or something along those lines. So being able to have a system with a bone mic type application that's just going to pick up on your audibles and allow you to freely communicate without ever keying anything up is key. You also want to make sure with hardline communication systems that you have a manifold or receiving port for all the inlets of rescuers and backup personnel and victims that enable you to appropriately manage tactically how you approach confined space. So there's some really unique things about ResComm, which is the system that we're going to be looking at today, that give you a lot of versatility and a lot of variable options. The first key element is that they do have hands-free devices for your entrance personnel. Outside, you can customize your manifolds to accommodate what you want to accommodate as far as number of ports for inlets and outlets for your audible listening component and your inlets for your rescuers. And then they have options between a standard comm line component, or they can embed their comm line in a rope. Now, the unique property about this rope is that it's not just a standard rope or waterproof type dive rope application. This rope actually carries NFPA ratings for G. So these have general use design loads per NFPA 1983. They also have very low stretch principles. This rope that we're looking at here today is a 13 millimeter rope. You can see on the side here it's a polyester based sheath. The elongation properties are posted right on the side, and at 1.35 kilonewtons we're going to end up with 300 pounds of force. That's going to result in a 1% stretch. It correlates with your load variables to 2.7 kilonewtons at 600 pounds, giving you that, in theory, two-person design load, which is going to give you a 1.5% stretch. So you can see that this is a relatively low stretch rope, which means it's going to react the way we want it to react in rope rescue applications. So how does that give you versatility? Number one, if you're using the rope with the embedded comm line as a dedicated tend line to your rescuers, it provides a lot of protection to the comm line itself, and it also enables you to utilize the comm line / rope as your dedicated tend line. You can put knots in this rope. You can put loads on this rope. You can run this rope through pulleys. You can do whatever you need to do to this rope, just like you would in real rope rescue applications. It is pliable. It's supple, it's easy to manipulate, so it affords you most of the principles that you're looking for in a life safety rescue line, and adds the great benefit of embedding your comm line within the system. So we are huge advocates with confined space of always encouraging rescuers and tactical sequence plans to say eliminate as many of the unnecessary redundancies that are going into the space as possible. It cleans up your entry and it reduces your entanglements. Combining the two entities of tend line and comm line are going to afford you a lot more streamlined operation for your entrance. The second option is you can take this comm line and then splice it to your airline using zip ties or some type of umbilical sleeve. You then end up with a dedicated umbilicus of air and comm. You can then run that secondary tend line, especially in vertical applications or gliding applications where you're doubling up rescuers and having individuals glide on the line. If you want to use the dedicated rope application for a vertical inlet, you can do so for the dedicated rescuers. Load that line as their primary belay line when they're in the vertical premise, and then once they go laterally, they're going to continue to move. The one thing I would encourage you to do is ensure that you're putting appropriate length midline knots for your connection points so that the tail of the rope extends with slack into the receiving box that mounts on the rescuer. You don't ever want to load those connections or those joints going into those control boxes. And that's true and applicable regardless of your hardline comm system. You even apply that principle if you're using standard coded comm line. You don't want to run this comm line to a control box and then potentially be pulling on that component without a PRISC or some type of progress capture device that allows the joint or the coupling to never get loaded. Another nice feature that Rescom adds to their coded comm line is this keeper component. This is the principle behind that, is that this enables you to clip this onto a component of your harness, and that way if this gets pulled, that's the point that's going to get loaded, not the connection or the coupling to the box. So those are the primary unique features about the comm line itself. And now we're going to get into the control box, the components of the bone mic, the earpiece, and how to set up all of these components and assemble them. When you open your control box, you're going to have four basic equipment categories. These are the volume control boxes and module boxes that are going to go on the rescuers and on the communication system attendant. There's one particular box that needs to be identified because it's the box that goes to the attendant. That box is very clearly going to have an off-on switch on the side of the box. This box requires batteries. All of the rest of the boxes require nothing. So it's important that you identify this box first and orient this box with the headset. The rest of the control boxes are going to go to your entrance or your rescue personnel. The boxes have Velcro sleeves on them with these simple tabs that enable you to, with versatility, attach these to whatever element of the harness or the escape pack that your rescuers are wearing. These boxes are very straightforward and simplistic. They have a single volume control on the side of the box. They have an inlet port on the top, which is for the headset and bone mic. And then they have an outlet port on the bottom, which is for the hardline communication system or the comm line that goes from rescuer back to the control module or the receiving manifold. So when you outfit your rescuers, each rescuer would get a headset with a harness, or a head harness I should say, and the bone mic application. These are designed, this portion, to go around the top of the head. This comes under the chin, much like a chin strap. This earpiece fits directly over the ear. This component comes down to this throat strap. The bone mic goes on the throat. This comes around the neck and latches back on itself. And then this needs to be appropriately adjusted per the rescuer so that it's snug, but not impeding or uncomfortable for the rescuer. Once those components are on the rescuer, he'll then take this trailing line that goes from his bone mic and his headset. He would attach it to his control box. When he attaches it to his control box, each male end has a small groove in it that lines up with a small extrusion on the receiving box. You line those two lines up, inserting all those prongs in, and then rotate the collar down, locking that component in place. Once that element is attached, you can then take your comm line and apply the same principle. You've got three basic pins that slide into three receiving points that are threaded in actuality around that bottom component. Line those up on the collar, line up your insert point, and rotate the collar until it clicks and locks into place. You now have a completed system at the rescuer. For the monitor or the attendant that's managing the comm system, he would then take that rescuer's comm line and he would attach that rescuer's comm line into the control box. The nice thing about the control box from the attendant's perspective is that it doesn't matter which outlets he uses. All of the outlets are completely versatile, whether it's his own personal outlet for monitoring and listening or whether it's outlets going to the rescuers. That rescuer now has a completed connection. From the attendant perspective, he would remove his headset. Coming out of his headset, he has one line, and this single line would attach into his control box, which again has the off-on switch. This line attaches the same as the rescuers on the top. Line it up, turn it in. You also have an adjustable volume control on the side of the attendant's box. Same Velcro straps for attachment. The attendant or monitor can then take the non-rope based comm line and make his appropriate connections. One to his control box, and then the other end going to the manifold. That's all there is to the system. So it's very straightforward, very clean and neat. You can see in this particular system, we have 1, 2, 3, 4 more additional ports to add for rescue personnel and potentially a victim if we want to be able to communicate with that victim. If for any reason we have a prolonged extrication, we can go ahead and rig them up, and that way the outside can communicate directly with them. That affords you some unique properties in case you have a scenario where you have an air malfunction or a problem for the rescue personnel and they have to abandon the space for a period of time. You can maintain streamlined communications with that victim. So organize your ports in such a fashion that you can accommodate everything you want to do tactically. It's also a great feature that ResComm allows you to change the color coding of the sheath of the rope as you order it. So when you put this in service, you can have a different colored rope for every entrant, which aids in identification, whether you're using these as dedicated 10 lines or if you're linking them to your air hoses. You can marry up your rope to your air hose systems, ensuring that you have clear identifications on both ends, whether it's your SAB control system as well as your control box for your comm system. You can have matching components to ensure that you can clearly identify which rescuers are on which systems and mitigate, manage any of their problems that they may have with these operating systems when they're in this space.